Hello, Dumelang, Sanbonani, Molueni, and a warm welcome to the Maths Genius video tutorial series brought to you by SABC Education. In these tutorials, we help you unleash the mathematical genius in you by showing you key mathematical concepts and how you can master them for success like a true genius.
Today we're going to be looking at sets and to see how to represent them diagrammatically through the use of Venn diagrams. Now a Venn diagram, I will show you one where you have a set A and a set B, right? Like that. So what you're simply saying is that everything that is in A is within this circle A, and everything that is in B is in that circle. So the area that is marked in red is the common area, where you're saying that anything that is within here is in both A and B. So that is your intersection. So you can mark that as the intersection. Intersection. And the sign for intersection is the upside U, like that. So this is the common area, right? The common elements. The common elements. Meaning that it's in A and also in B. It's in both sets, right? We can even have 3-4 sets and have common areas, like if you draw it like that. So this area in black is common to A and B. But now, if you look carefully, you'll see that this area is common to A, B, and C. So that means that this is the intersection of all sets, the 3 of them. So it's always important when given sets to be able to represent them diagrammatically and be able to know what each of the areas represent. Now, going back to our original diagram, you'll see that if the red part is the intersection, then what about this blue part here? What do we call this blue part? The blue part represents the area in A that is not in B. So in other words, this blue area, we'll call it A intersection B complement. What does B complement mean, right? B complement means not in B. So we're saying it's in A and not in B. So it's in A but not in B, because B starts from here going that way. So this blue part is that one which is in A but not in B, right? And then if you were to use a green color for this other side, like that. Now the green area, this part is in B but not in A. So B in B but not in A. So the A complement means not in A. So you've got your 3 different regions like that. You can even extend it to 3, 4, 5 sets depending on what you're working on. Now, when you combine this area plus this area plus that area, what do we get? Remember, we spoke about unity, and we said if sets are united, you're bringing in everything together. So if we take this area, A intersection B complement, right? And then we add that to A intersection B, right? This is A intersection B. And then we add that to B intersection A complement. So what we've done is saying those in B only, those in A only, those in both, and those in B only. If you put everything together, then you're going to get A union B. So A union B is everything. The blue, red, and green put together give you A union B. So this is how Venn diagrams speak volumes of what we are doing. But what about now, if we were to put a superset, right, like this, and say, let's call this capital M, this big box around, right, like that. Let's say we have a big box like that now. And then we have an element, X, let's call it X, right? Please, the X shouldn't frighten you, it's just a number. It's a letter representing some number that's unknown. So it's just an X, right? So, if somebody is to ask you, where is X? I can explain it and say, X is in M, right? So X is an element of M, right? X is an element of M, but I can also say X is not an element of A union B, meaning that X is not within the blue, red, and green areas. So you just need to be able to describe that. So what is this area? What is that area that X is in? Clearly we're saying X is not an element of A union B, so we are saying this implies that X is actually an element of A union B complement, meaning that it's not in A union B. So these are concepts that you should actually understand how to use union and intersection interchangeably to describe where an element lies and to describe how many elements are in a certain region. So this is a very high-level introduction to Venn diagrams, and I hope that this has sparked some interest for you to actually go research further and find out more information about this. Thank you very much.
Thank you for taking the time to watch this video. Unleash your mathematical genius today. If you have any maths questions, you can post them for free on www.mathsgenius.co.za or email them to info@mathsgenius.co.za.